Okay, rational exponents. These right here are the definitions. Basically, when you have a rational exponent, that means like a fraction exponent, so x equals 1 over a, it equals to the eighth root of x, all right? So for example, if you have something like x to the 1/3, that will be the cube root of x, or x to the 1/5 will be the 5th root of x. Okay, no, we're not going to have to calculate fifth roots, but we do want to be able to move back and forth between rational exponent and radical form. Okay, and when you have something like b over a, how this works is the bottom, if you have a fraction exponent, the bottom is the root, the top is the power. So it's power over root. So if you have something like x to the 3/2, the 2 is the root, so it's going to be the square root of x to the 3rd power. Okay, and you can write the 3, so this b right here is on the way outside, or you can write it on the inside, it doesn't matter. All right, so this front page, we're just going to write each expression in radical form, or write each radical in exponential form. So the first one is radical 47. That is the square root of 47, so you would write that as 47 to the 1/2 power. Okay, because it's a square root, it's 1 over 2. 11 to the 1/7. 7 is the root, so it's going to be the 7th root of 11. Okay. The next one, 300 to the 3/2. The 2 is the root, the 3 is the power, so it's going to be the square root of 300 to the 3rd. Now, you can also write that the square root of 300 all to the 3rd. Those are interchangeable. It doesn't matter which way you write it. Okay. And the next one, it's the cube root of everything there on the inside. So I think the easiest thing would be to take the inside and take it to the 1/3 power. Okay, so you would have the whole inside in parentheses. All right, so that's just a little practice, changing from rational exponent to radicals and from radicals to rational exponents. Okay, so moving on, now we're going to do evaluating sum. Okay, so with these, it's just using the root and the power. Okay, the denominator is the root, the numerator is the power. So I'm going to start on the right side. This one right here, I always calculate the root first. Okay, so the cube root of -64. We've done that. We know that is -4. And then 2 is the power, so -4 squared is 16. Okay. The next one, 81 to the -1/4. Again, I always do the root first. So I'm going to do the 4th root of 81. I know we haven't talked about that yet. But if you do 3 times 3, that's 9. Times 3 is 27, times 3 is 81. So the 4th root of 81 is 3. No, I will not test you on anything that has a 4th or a 5th root. Okay, so 3, and then the power is going to be -1. So 3 to the -1, remember that negative exponent moves at the denominator, so it's 1/3. Okay. The next one, -27 to the 2/3. This one is a little tricky. We need to go back and remember that a negative on the outside, like a -x, really means -1 times x. Okay, so this negative right here, that 2/3 power is only to the 27. Okay, the negative is out in front. So I like to write it as -1 times 27 to the 2/3. All right, now 3 is the root, so I'm going to do the cube root of 27. We've just been doing that, right? Cube root of 27 is 3. And then I'm going to square it. 3 squared is 9. And then don't forget, we're going to multiply it by -1. So it's -9. Okay. 32 to the 2/5, that is the 5th root. So we have the 5th root of 32. No, you won't be tested on this. I'm sorry, I didn't pick great examples here. But the 5th root of 32, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the fifth root of 32 is 2, and then 2 is the power. 2 squared is 4. Okay. The next one, 49 to the negative 1/2. Again, the 2 is the root, so root 49 is 7, and then negative 1 is your power, so that becomes 1/7. The next one gets into using our rules. So this is power to a power. Remember, we multiply when it's power to a power. So that's negative 5 times 1 over 15 is negative 5 over 15, which reduces to negative 1/3. Okay? So from there, 3 is our root, so the cube root of 8 is 2. Negative 1 is our power. 2 to the negative 1 is 1/2. Okay. Next page, we have more of these. 7 to the 1/4 to the negative 4. Again, that's power to a power, so we have to multiply. 1/4 times negative 4, we get negative 4 over 4, which is negative 1. So 7 to the negative 1, that's an easy one, that's 1/7. The next one, we have to figure out the inside first. All right, 8 to the 1/3 and 27 to the 1/3, we need to figure out them individually. So the 1/3, that 3 on the bottom, means the cube root of 8. We know that the cube root of 8 is 2. And then 27 to the 1, and then that's just 1 power, so 2 to the first is just 2. Okay, and then 27 to the 1/3, that is the cube root of 27, which is 3. 2 plus 3 is 5, and we do 5 cubed. 5 times 5 is 25, times 5 is 125. Okay. The next one here, we have power to a power again. So root 3 times negative root 3. Positive times a negative is negative. 3 times 3 is root 9, which is negative 3. So 6 to the negative 3. 6 times 6 is 36. Times 6 is 216. So the negative power means we do 1 over 6 cubed, or 1 over 216. Okay, so 3 more examples. This is, again, just like one we just did on the last page. 16 to the 1/2, we're going to figure that out individually. 2's on the bottom, so it's the square root of 16, which is 4. 4 to the first power is just 4. And then 64 to the 1/3. 3 is on the bottom, so it's the cube root of 64, which is 4. 4 to the first is 4. So this one, we end up with 4 minus 4, which is 0. Cubed is just 0. All right, the next one, we have the power to a power. Okay, so 2/3 times negative 2. 2/3 times negative 2 is negative 4/3. So that's negative 27 to the negative 4/3. So again, that negative out front, the 4/3 is not to that. Okay, so it's just we're going to do the cube root of 27, which is 3. We're going to do 3 to the negative 4, which is 1 over 3 to the 4th, or 1 over 81. And then we're going to make it negative. But let's look at that a different way. If we do negative 27 to the 2/3, if I do that inside first without doing power to a power, we're going to do the cube root. We did that on the first page. Cube root of 27 is 3. 3 squared is 9, and then the negative makes it a negative 9. And then we take that to the negative 2. That's going to become positive. All right, so I see what I did. Okay, so when it's this whole thing to a negative 2 power, because it's this whole thing and the negative 27 is in parentheses, that we're going to square that. That means it does become positive. Okay, that's a tricky one. You need to think about it as it's in parentheses to a negative 2 power, and when you square something, it becomes positive. Okay, so that is going to be a positive 81. And that's all because the squared is on the outside. All right, so ones like that, if you can figure out the inside first, maybe do that, or just recognize, okay, I'm squaring a negative, my answer is going to be a positive. Okay. And the last one, we have the square root of x cubed y to the negative 2. So let's do the square root. Y goes to the bottom, so it looks like this. And then we're going to cube that. Two different ways you can do that. Why don't we simplify them each individually first, right? The square root of y squared is y. Square root of x cubed, I'm going to break that down to x squared and x. Square root of x squared is x, root x. And then we're going to raise each of those to the third power. All right, so the x to the third is fine. That's easy. Y to the third is easy. With root x to the third, sometimes it's easier to say, okay, well, root x is x to the 1/2. To the third power means you have x to the 3/2. Okay, that would be if I do the square root of x to the third. So it's the square root of x to the third. X to the third can again be broken down to, so my original x to the third, that's going to become x root x over y to the third, which is, oh my gosh, I'm running out of room. I'm going to write it up here. X to the fourth root x over y to the third. Okay, and we can go over that again next class. All right, so go ahead now and try the topic for practice.